Welcome back to the deep dive. So if you've ever ordered anything online, and let's be honest, that's pretty much everyone listening right now, you are very familiar with what we call the last mile.
It's that final crucial step.
Exactly. The growth in e-commerce has been, explosive. And the pressure on logistics companies to deliver faster, more reliably, and, cheaper has just never been higher.
And that final stretch, from the local distribution center to your front door, it's always been the most complex part of the journey.
Right, the most energy intensive and frankly the most expensive stage of the entire process.
For sure.
So today we're doing a deep dive into a technology that is fundamentally restructuring how companies are solving this puzzle. Our mission is to understand what AI-driven digital twins are and why they are completely revolutionizing delivery vehicles.
It's a genuine game changer. I mean, we're not just talking about small, incremental optimizations here. This isn't just a better route planning app. We're talking about creating a whole virtual ecosystem, a space where vehicles are designed, tested, and constantly refined using massive amounts of real-world data before a single physical bolt is even tightened.
Before any prototype is even built.
Precisely. The digital twin enhances the design, it simulates performance with incredible accuracy, and it refines all these complex processes. The end result is a clear path to better efficiency, much lower costs. And this is critical, a real measurable reduction in the environmental footprint of these huge fleets.
Okay, let's unpack this then, because digital twin is one of those terms that still sounds a little bit like it belongs in an engineering textbook.
It does, but the concept is fairly straightforward.
So what exactly is a digital twin when we're talking about, say, a delivery van?
Simply put, a digital twin is a living, breathing, virtual replica. It's a software model that perfectly mirrors a physical asset.
So the van in this case, or maybe even the whole fleet.
The whole fleet, exactly. And not just the vehicles, but the environment they operate in, too. It's created by integrating real-time data that's streaming from sensors on the actual physical vehicle.
What kind of data are we talking about?
Oh, everything. Speed, GPS location, engine temperature, how the driver is behaving, how the payload is distributed inside. All of that is combined with sophisticated simulation tools and, of course, powerful AI algorithms. This virtual mirror runs completely parallel to the real world.
So if I'm an engineer using this, what specific factors is this twin simulating? It's got to be more than just horsepower and speed, right?
Oh, far more. This isn't a static model. It's a dynamic virtual environment. It simulates every single variable that impacts performance and cost.
For example?
Well, for a standard combustion engine vehicle, it's simulating fine-tuned details, like fuel consumption when the van is fully loaded, going uphill in the middle of heavy traffic.
Again, for an EV, an electric vehicle.
For an EV, it's even more crucial. It simulates battery degradation over time, thermal load on a hot day, and energy use based on things like how much the AC is running, or how often the driver is using regenerative braking in city traffic.
The key insight here, then, must be that you can separate the research and development from, actually building things.
That's it. Instead of spending months and a ton of money building a physical prototype, then testing it slowly on some closed track, an engineer can virtually test 1,000 different versions of a chassis design or a new battery pack in a single day.
Wow.
That benefit alone just compresses the development timeline and slashes the costs.
That economic disruption is huge. Okay, so let's move to the brain of the operation, the AI-driven part. The twin is the model, but it sounds like the AI is really the engine driving the innovation. What's it doing that's more than just processing data?
This is where we move beyond simple data crunching. We're talking about predictive and even prescriptive analytics. The AI is integral because it can handle a level of complexity that is, well, just impossible for humans to model manually.
Okay, so it's finding patterns we'd miss.
It's analyzing these vast, multivariate data sets, data from real vehicles mixed with data from the simulation, and it identifies these nonlinear relationships. It doesn't just see that a heavy load drains the battery faster.
Right.
It can determine that a heavy load combined with a 90-degree day and a driver who brakes aggressively before the 10th stop leads to a very specific, say, X% greater chance of range anxiety.
So the AI is spotting these subtle intersections of variables, the things you wouldn't even think to look for that are creating these inefficiencies.
Exactly. And once it spots those patterns, it doesn't just flag it. It uses predictive analytics to suggest precise, actionable changes. It goes from being a diagnostician to really a co-designer.
It's providing solutions.
Prescriptive solutions. So take the design of a new EV fleet. The AI can optimize the vehicle's entire structure, like where to put the battery or what materials to use by running simulations that factor in the typical payload, where the fleet will operate, rocky roads versus smooth highways, and the required battery longevity. It gives the engineer an optimal blueprint for that fleet's exact mission.
And I'm guessing that operational data also feeds into routing. We've had routing software for years, but what does the digital twin add?
It adds this dynamic, granular depth. Traditional routing looks at distance, maybe some real-time traffic. A twin, with AI, runs a simulation of the delivery itself.
The entire delivery.
The whole thing. It recommends the most efficient route by factoring in distance, yes, but also weather, historical road quality issues that might stress the vehicle, and the delivery time windows. It might even suggest a slightly longer route if it knows the shorter one has 4 long stoplights that will just drain an EV battery in stop-start conditions.
Okay, this is where it gets really interesting for me. Simulating scenarios that are just too dangerous or expensive to test in the real world. What's one of the toughest scenarios you can test virtually that would be, completely out of the question with a physical van?
That's where the twin really proves its worth. You can simulate long-term structural fatigue. You could run a simulation of a van driving the equivalent of 10 years in just 6 weeks.
Wow.
And you could test how often a specific part, like a suspension strut, would fail under the continuous stress of hitting potholes, all without destroying a single physical prototype.
Or I imagine weather is a big one.
A huge one. Imagine a logistics company needs to know how a new vehicle design handles a polar vortex blizzard in, say, downtown Chicago during rush hour.
That sounds impossible to test for real.
It is. It's dangerous, expensive, hard to standardize. But in the digital twin, you can run that scenario 1,000 times. You can adjust the severity of the ice, the depth of the snow, the level of gridlock, to refine all the safety systems and the vehicle's handling dynamics.
Let's dig into that EV range anxiety example you mentioned, because that is a massive operational headache for anyone managing an electric fleet.
It really is. EV range is so sensitive to outside factors. So a digital twin of an electric van, it's ingesting data on the driver's habits, the temperature, the payload weight, the route's topography. It can run a simulation that shows the exact moment, down to the minute, that the vehicle would run out of battery if it gets stuck in 2 hours of unexpected traffic.
Which sounds like a nightmare for a logistics manager.
It is a nightmare, but the AI turns that anxiety into proactive planning. The model predicts that exact depletion point, and instead of letting the van run dry, it suggests the best time to break from the route for a charge.
And it probably recommends the best station, too.
It recommends the specific station that will cause the least overall delay to the rest of the deliveries. It's optimizing the route and the energy strategy at the same time.
And that ability to predict failure links right into maintenance strategies, doesn't it? Because every van in a fleet isn't used the same way.
Absolutely. Some are driven harder, carry heavier loads, or operate on rougher roads. The digital twins don't just stop at the design phase. They actively monitor operational wear and tear based on that real-world data streaming back from the fleet.
So it knows which specific parts are under more stress.
Exactly. By cross-referencing component specs with actual usage patterns, the AI can predict when a specific part is likely to fail long before it shows any traditional signs of wear.
Which means companies can shift to predictive maintenance.
That's the goal. You abandon inefficient, calendar-based schedules. Instead of taking a perfectly good vehicle off the road every 5,000 miles, you wait until the digital twin sends an alert that, say, a specific brake pad in this particular van is approaching its failure threshold.
That would radically reduce downtime.
It does. And it ensures the whole fleet is always running at peak efficiency.
That predictive ability is just huge. But the twin's job isn't done once the vehicle is built, right? It enters a kind of continuous loop.
It has to. That's the crucial step for continuous improvement. Once the vehicles are out in the real world, their sensors are constantly collecting new performance data.
Like what?
Like how the suspension handled a sudden heavy bump, or the battery temperature during a fast charge, or how often the driver accelerated hard.
And all that real-world data gets fed back into the virtual model, which makes the twin smarter and more accurate over time.
Precisely. The digital twin is constantly learning from actual performance. It creates this iterative improvement loop that's based on hard operational data, not just theory. It's like a perpetual design review.
Can you walk us through a specific example of that, where data from a physical vehicle actually forced a design change in the virtual twin?
Certainly. Imagine sensors are collecting data on how different load distributions affect handling. A logistics firm might notice that when heavy packages are loaded high up in the cargo area, the vehicle uses, say, 5% more energy on tight urban corners.
Because of instability or something.
Exactly. Instability, increased drag,
Huh.
maybe more brake usage. The AI analyzes this correlation, and then it proposes a physical design tweak for the next generation of that vehicle.
Like changing the cargo area.
It might be modifying the internal layout to force loads lower down, or maybe subtly improving the suspension's damping rate to compensate. That physical change was directly caused by the data feedback loop.
This feedback loop has obvious cost benefits, but it also ties directly into sustainability, which I know is a huge driver for these companies.
It's vital for sustainability. By optimizing vehicle designs, especially for electric and hybrid models, the AI is ensuring maximum energy efficiency. Better routes mean fewer miles driven. Smart load management means less wasted energy. It all translates directly into fewer emissions.
And they can even design the vehicle based on where it's going to be operating, which gets at that huge challenge of dense urban delivery.
The urban challenge is maybe the hardest piece of the last mile puzzle. Digital twins let engineers design vehicles specifically for crowded cities. They can simulate navigating tight alleys, tricky parallel parking, delivery stops that block traffic.
So it's not just about the engine or battery, but the physical shape and size of the van itself.
Right. The simulation allows for optimizing the vehicle's exterior parameters.
Mm-hmm.
Its width, its turning radius, its overall weight. By focusing on compactness for city use, the digital twin helps design vehicles that minimize their physical and environmental impact on these dense urban landscapes.
We've talked a lot about the potential here, but this isn't science fiction anymore. Which big players are actually using these systems?
Well, our sources confirm that major logistics powerhouses, companies with huge global fleets like Amazon and UPS, are already heavily exploring and deploying aspects of this.
So they're vetting designs right now.
They are. They're optimizing their next generation of delivery vans before they ever commit to mass production, ensuring they're as efficient as possible from day one.
And looking ahead, the potential gets even bigger when we start talking about vehicles that don't have a human driver.
Absolutely. Digital twins are foundational for the next era of logistics, which is autonomous delivery. You simply cannot safely deploy self-driving logistics without a robust virtual proving ground.
A place to test them safely.
A place to simulate millions of miles of complex, unpredictable urban driving. Testing the autonomous software's response to everything. A pedestrian stepping out, a weird traffic signal, road construction, all in a completely risk-free virtual world.
Before that autonomous vehicle ever touches a real street.
Exactly. And as AI algorithms get more sophisticated, as sensor tech and computing power improve, these virtual models will only become more precise. This really promises a future with lower costs, faster delivery, and a significant, verifiable reduction in environmental impact across the entire supply chain.
So if we step back, the key takeaway here is that AI-driven digital twins are a truly transformative shift. This isn't just an upgrade, it's a complete restructuring of how last-mile vehicles are conceived, tested, and optimized. It's forcing the industry toward data-driven decisions that balance performance, efficiency, and sustainability.
That's a perfect summary. It's a whole new paradigm.
So what does this all mean for you, the person waiting for your package? Well, next time you order something online and you see that delivery van pull up, just consider that every stop it makes, every turn it takes, even the vehicle's fundamental design, it might have been perfected thousands of times in a virtual world.
A world designed to handle blizzards and bumper-to-bumper traffic.
A world designed for that exact moment, before that vehicle ever hit your street. It's a fascinating thought. And while we focused a lot on design and routing, the sources make it clear the most rapid application will be in accelerating autonomous tech. So here's something to think about. How much faster might the transition to self-driving logistics happen now that these sophisticated digital twins are already in place, capable of safely testing those complex, dangerous urban scenarios that previously stalled everything? Something to mull over as you track that next delivery.